Welcome to the Navakokon Education Society's Divize College online session conducted by Shriram Dandekar. In this session, we are going to consider the nth ordered derivatives of some standard functions. Let us begin with one simple thing, simple function y equal to x to the power m. Here I am considering m as a positive integer and I am considering one n which is smaller than this m. The first derivative of this y dash is m into x raised to m minus 1. The second derivative is y double dash m into m minus 1 into x raised to m minus 2. Y triple dash m into m minus 1 into m minus 2 into x raised to m minus 3. Observe here, for first derivative only one constant is here. For second derivative 2 constants. For third derivative 3 constants. For third derivative m minus 3. For second derivative the power is m minus 2. So continuing in this way, for the nth derivative, n is smaller than m is positive, m minus 1, m minus 2, dot, I want m minus n plus 1, because this number is 1 smaller than this 3, and here x raised to m minus n. m minus n plus 1. This number is 1 smaller than this number. What if m is equal to n, which is greater than 0? If m equal to n, then here m equal to n gives us 1 and m equal to n gives here 0, and we get the nth order derivative is nothing but nth order derivative. It is m minus 1 dot into 3 into 2 into 1 into x raised to 0, that is m factorial, but m is equal to n, so it is n factorial. Nth order derivative of x raised to m or x raised to n is m factorial or n factorial when m is equal to n. You know that this is a constant one, and when we differentiate a constant we get 0. So next derivative is 0, and therefore when n is greater than m we get the nth ordered derivative is 0. Let us see how to find the second order derivative, nth order derivative for ax plus b bracket raised to m. Here m is greater than 0 and I am going to assume m is greater than n. So the first derivative y dash is derivative of bracket raised to m is m into bracket raised to m minus 1 into derivative of the bracket ax plus b. This is equal to m into ax plus b raised to m minus 1 into derivative of ax plus b is a. So the first derivative is a raised to 1 into m into bracket ax plus b bracket raised to m minus 1. The second derivative y double dash is equal to a into m, constants as it is, derivative of bracket raised to m minus 1. It is m minus 1 into ax plus b, that is bracket raised to m minus 2 into derivative of the bracket is a. So it becomes a square into m minus 1 into ax plus b bracket raised to m minus 2. Continuing in the same way, the third derivative we get a cube into m minus 1 into m minus 2 into ax plus b raised to m minus 3. And for m greater than n, which is greater than 0, the nth order derivative is a raised to n into m minus 1 into m minus 2 into dot 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 into m minus n plus 1 into ax plus b bracket raised to m minus n. If m is equal to n, then this derivative becomes y raised to m is equal to a raised to n into m factorial into ax plus b bracket raised to 0, that is a raised to n into n factorial. This is because m equal to n. And the next derivative, that is when m is smaller than n, the next derivative must be 0 because this is constant. This is constant, and therefore the mth derivative or nth derivative for m smaller than n is 0. Let us see nth derivative of y equal to e raised to 3x minus 4. First derivative y dash, e raised to bracket derivative is e raised to bracket into derivative of bracket, that is derivative of 3x minus 4 is 3. 3 into e raised to 3x minus 4 is first derivative. The second derivative is 3 into e raised to 3x minus 4. Derivative of e raised to 3x minus 4 is itself into derivative of 3x minus 4 is 3. So it is 3 square into e raised to 3x minus 4. Similarly, we get the third derivative is 3 cube into e raised to 3x minus 4. Continuing in this way, the nth derivative is 3 raised to n into e raised to 3x minus 4. Suppose y equal to log 5 minus 2x and I want its nth derivative. The first derivative y dash is 1 upon 5 minus 2x into derivative of 5 minus 2x. This is minus 2 upon 5 minus 2x. The second derivative y double dash, derivative of this minus 2 constant, derivative of 1 upon bracket is minus 1 upon bracket square into derivative of bracket is minus 2. So I can write this as minus 2 square into minus 1 upon 5 minus 2x bracket square. The third derivative y triple dash is equal to these constants as it is, minus 2 square into minus 1. Now derivative of 1 upon bracket square, that is derivative of 1 upon bracket raised to m. The formula is minus m upon bracket raised to m plus 1. Using that formula, the derivative of 1 upon 5 minus 2x bracket square is minus 2 upon 5 minus 2x bracket cube into derivative of 5 minus 2x is minus 2, and therefore the third derivative y triple dash is minus 2 cube into minus 1 into minus 2 divided by 5 minus 2x bracket cube. Let us take one more step and we get the fourth derivative, minus 2 raised to 4 into minus 1 into minus 2 into minus 3 divided by 5 minus 2x bracket cube. Continuing in this way, we get the nth order derivative as minus 2 raised to n, because for fourth order derivative I get minus 2 raised to 4, and for these numbers I should get minus 1 into minus 2 into dot 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 into minus n plus 1 minus n plus 1 divided by 5 minus 2x raised to 5 minus 2x raised to n, because for third order derivative we are getting 3 in the denominator, for second order derivative we are getting index 2 in the denominator, for fourth order derivative we are getting index 4 in the denominator. So for nth order derivative I should get index n in the denominator. Now here for fourth derivative I can think this as minus 2 raised to 4, negatives are 3, so minus 1 raised to 3 into 3 factorial divided by this bracket raised to 4. So generalization gives me the nth order derivative as minus 2 raised to n into minus 1 raised to n into n minus 1 factorial. This is because 2 into 1, that is 2 factorial for third derivative. For fourth derivative it is 3 factorial. So for nth derivative it is n minus 1 factorial and divided by 5 minus 2x bracket raised to n. This is the nth derivative of log 5 minus 2x. Let us find the nth order derivative of y equal to sine 4x minus 7. The first derivative is y dash is equal to sine bracket derivative is cos bracket into derivative of bracket this is equal to the derivative of 4x minus 7 is 4 times sine pi by 2 plus 4x minus 7. This is because sine of pi by 2 plus theta is cos theta. The second derivative is y double dash 4 into derivative of sine is cos pi by 2 plus 4x minus 7 into derivative of pi by 2 plus 4x minus 7 is 4. So 4 into 4 is 4 square into, again, cos means sine pi by 2 plus theta. So I get here sine pi by 2 plus pi by 2 plus 4x minus 7. So the second derivative is 4 square sine 2 into pi by 2 plus 4x minus 7. Continuing in this way, the third derivative is 4 cube into sine 3 into pi by 2 plus 4x minus 7. The fourth derivative is 4 raised to 4 sine 4 into pi by 2 plus 4x minus 7. And the nth derivative is 4 raised to n sine n pi by 2 plus 4x minus 7. Let us take the next problem, y equal to e raised to x into cos bx plus c. The problem is slightly bigger and we have to understand it carefully. The first derivative, for first derivative we have to use the product rule, u into v rule. E raised to x as it is into derivative of cos bx plus c plus cos bx plus c as it is into derivative of e raised to ax. This is equal to e raised to x into cos bracket derivative is minus sine bracket minus sine bx plus c into derivative of bx plus c. I am not going to increase one more step, so the derivative of bx plus c directly written b plus cos bx plus c into derivative of e raised to ax is e raised to ax into derivative of ax is a. I can take e raised to ax common. Inside the bracket I will get minus b sine bx plus c plus a cos bx plus c. I will rearrange the terms and I will multiply and divide by square root of a square plus b square. So e raised to x into square root of a square plus b square, inside the bracket a upon under root a square plus b square into cos bx plus c minus b upon under root a square plus b square sin bx plus c. Multiplying and divide by under root a square plus b square. This is equal to, now before I move to the next step, let me explain why I have taken this a upon under root and b upon under root. If I square and add these two terms, I will get a square upon a square plus b square upon a square plus b square, which is equal to 1. So call any one of them as sin alpha, the other thing will be cos alpha. Now here the original function given is the cosine function, and therefore I want this answer to be a part of cosine function, and therefore I will put a upon under root a square plus b square is equal to cos alpha, and therefore it becomes b upon under root a square plus b square is equal to sine alpha, and therefore tan alpha is equal to b by a, and therefore alpha is equal to tan inverse b upon a, which is a constant. And therefore using this substitution I get the derivative y dash is equal to e raised to ax into square root of a square plus b square into cos alpha cos bx plus c minus sin alpha into sin bx plus c, because a upon under root is cos alpha and b upon under root is sin alpha. This is equal to square root of a square plus b square into e raised to x into, now this is the formula of cos a cos b minus sin a sin b. The formula used is cos of a plus b, so this becomes cos of a plus b. I am rearranging the terms bx plus c plus alpha. So the original y was e raised to ax into cos bx plus c. The first derivative is square root of a square plus b square into e raised to x cos bx plus c plus alpha. Let us differentiate this with respect to x, and we get y double dash. The second derivative is equal to square root of a square plus b square as it is. Now derivative of e raised to ax into cos bx plus c plus alpha, using product rule, this is under root a square plus b square is constant, e raised to x into derivative of cos is minus sin bx plus c plus alpha into derivative of bx plus c plus alpha is b plus cos bx plus c plus alpha as it is into derivative of e raised to x is a times e raised to ax. Taking e raised to x common, under root a square plus b square into e raised to x into bracket a cos bx plus c plus alpha minus b sin bx plus c plus alpha. Now again multiply and divide by square root of a square plus b square, so it becomes square root of a square plus b square bracket square into e raised to x into bracket a upon under root a square plus b square cos of bx plus c plus alpha minus b upon under root a square plus b square into sine of bx plus c plus alpha. Again This a upon under root a square plus b square is cos alpha and this is sin alpha. So I get cos alpha cos theta minus sin alpha sin theta. It is square root of a square plus b square bracket square into e raised to x into cos alpha cos bx plus c plus alpha minus sin alpha into sin bx plus c plus alpha. So the second derivative becomes square root of a square plus b square bracket square into e raised to x into cos of bx plus c plus alpha, that is bx plus c plus twice alpha. Continuing in this way, we get the nth order derivative as under root a square plus b square raised to n. For second derivative it is bracket square e raised to x as it is. For second derivative the last term is cos bx plus c plus 2 alpha. So for nth derivative it is cos bx plus c plus n alpha. This is your nth order derivative for e raised to x into cos bx plus c. Thank you.